talking about general probability distributions. What we're looking at now is special cases at what's called binomial distribution. And there are some set requirements that have to happen for this to be a binomial. You want to jot these down. These are the requirements. So to be a binomial, there has to be a fixed number of trials. I can't just say I'm going to roll a dice until I roll a 6. I have to say I'm going to roll it 5 times and see how many 6s I get. There's a set number of trials. We call that n. The trials are independent. So what happens the first time doesn't change what happens the second time. Big thing, there's only 2 possible outcomes, success or failure. If I'm talking about 6s, either I get a 6 or I don't. I wouldn't just be recording how many of each number I got. We call lowercase p the probability of success and lowercase q the probability of a failure. And the probability of success is the same for every trial. So some of these would be binomial. Player rolls a pair of die 10 times. The number of x of 7s is recorded. So we're talking about the sum of 7s. So would this be binomial? Do I have a fixed number of trials? Yes, I have n trials. The probability of getting a 7, would that be the same each time? Yes. If I'm talking about 2 dice, we could get a 7 with a 6 and a 1, or a 1 and 6, 2 and 5, or 5 and 2, 3 and 4, or 4 and 3. So there would be 6 out of 36 total options, which is 1 6. So we have a fixed probability of getting a 7. So what would be Q, the probability of not getting a 7?
5 and 6.
Okay. So yes, this is binomial. What I rolled one time doesn't change what I rolled next. Okay, B. An official with the FFA randomly selects airline flights until she finds 10 that were not on time. The number of flights X that needs to be selected is recorded.
It's not because she didn't have a set amount. She didn't have I'm only going to choose the first 15 that come in for late.
Right, there's not a fixed number of trials. She isn't just going to look at 15 or 20 flights. So there's not an n in this case, not a set number of trials, so that one is not binomial. In a class of 30 students, 55% are female. The instructor randomly selects 4 students. The number of females selected is recorded. Okay, we're going to this example. I kind of used that, didn't I? Would this one be binomial? No. The trials aren't independent.
You should poke your head out one day and be like, you guys please quiet down.
I'll do that tomorrow when the metal starts arriving.
Seriously, just open the window and poke your head out and look at them.
Yeah,
Give them a heart attack.
So this one is not, because after you pick the first female, that changes the probability for the next one. So those would not be independent. It's not binomial. Okay. Now look at another example. The 11 largest air carriers had an on-time percentage of 79% in May 2008. Suppose that 4 flights are randomly selected from May 2008, and the number of on-time flights X is recorded. Construct a probability distribution for the random variable X using a tree diagram. I put this on here because your book randomly will mention a tree diagram, and we really haven't done any. So I'm going to draw a tree diagram to show all my possibilities. Okay? If I'm talking about a flight, we have, if it's binomial, two outcomes, success or failure. In this case, success would be what? On time, and failure would be late or earlier, not on time, right? Okay, so for the first airplane, can we agree it would either be a success or a failure? It's either on time or it's not. How many airplanes am I looking at? 4. So for the second one, it would be either on time or not, right? So it could have been that the first one's on time and the second one is. The first one is on time and the second one isn't. Or regardless of what happened the first time, oops, the second one could either be a success or a failure. But I have 4 flights. So for the third one, what do I need to do on each of those? Yep, we have 2 more branches coming off each of these for the third flight.
I wrote it into like 6th grade.
We don't do it very often, but I figured it would probably be beneficial just to make sure you knew how. So this is the first flight, the second flight, the third flight, and now we need to do the fourth and final, so 1 more.
What's this even show?
In just a second, I'll show you.
How would possible difference?
It'll help us with our probability calculations here.
So like all successes. It's like 4.
Okay, we've kind of done the same thing. We had like that one scenario, I think it was on study guide. It was like you have 3 stoplights on the way home. What's the sample space? And we said it could be green, 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 or green, green, red, or green, red, green. And we listed all those. That's kind of what this is doing. It shows me we could have success, success 4 times, or first 2 success, failure, and then a success. It gives us all the outcomes. Okay, I'm asking you to create a probability distribution here. That's what you did in the last section. So we have to do our x and our p of x. Okay, it told us in the problem that x was the number of on-time flights. So what are my options for x? Well, what numbers?
Oh, 0. Yeah,
0, 1, 2, 3, 4. That would be the number of flights that were on time. So we could calculate the probability of each.
So 0 is 4 out of 12?
Okay,
Or 1 out of 12?
so here's the thing though. The problem told us we had 4 flights, right? What was the probability of success? The probability that a flight was on time? So that's like our P. Q is 1 minus P, so it'd be 0.21. So you have 79% chance of being on time, 21% chance of being late. So for no flights being on time, how many times does that happen up here? Just once. If I want to calculate that probability, if none of them are on time, that meant all of them were late, so all 4 of those have probability of 0.21. So if we type in 0.21 to the 4th, we get, I'm going to keep 2 decimal places, 00194. Okay, that is the probability of no flights being on time. Probability of 1 flight being on time. This is where the diagram helps us. How many times do we just have 1 flight on time? So that means we had 3 failures and a success.
Oh, 1.
Okay, here's 1. This would be 1, 2, wouldn't it? 2.
So it's like 0.7 times 9 times 0.21 to the 3rd power, because 3 failed.
4. So it happened 4 times. Okay, so I'm just going to put 4 times. We had 3 fail, the third.
Why is that one 4 and not to the 4th power? Like, why would you do the other one to
Okay.
the 4th power and not this?
So, think of it this way. How we've done these problems before. If I just wanted one on time, that could have been yes, 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 no. Yes, yes, no, yes. So we would have listed our sample space, right? And then we know the probability of success is 0.79, so you would write this out. And failure would be 0.21. And you would have those 4 numbers multiplied for all 4 of these scenarios. So I just said we're going to have 4 of those, and then, oh, I wrote that backwards, so it should be the 0.21s, but I flipped my probabilities there. But since it came up 4 times, instead of just writing each one individually and adding them, I'm saying we have 4 of those scenarios. We were late 3 times, so 0.21 to the third. We were on time once, so times 0.79.
So the first one is just like it has a 1 in front of it because there is one like that.
Yes.
Okay, I think that's right. I confused because it was different from the first one.
We get 0.02926. Okay, 2 flights on time. So you need to use this diagram to count how many scenarios, how many times do we have 2 flights on time. So like here, that would be 3, but I could have the first 2 and not those, so there's 1. We could have, let's see,
Success, fail, success, fail.
1,
It's almost easier.
3, Just wanted to show you the options. 4. So I got 4 options. Is that right? No. Wait. We have 1, 2, 3, 4.
Last 2.
So is this 2 or success?
We should get 6 of those, where we have 2 success and 2 failure. Which, if you just wrote out your sample space, you can get the same way. Okay. If 2 of them are on time, that meant 2 are late. So 0.21 squared and 0.79 squared. Equals 0.16514. Okay, 3 of them on time. How many times does that happen? So it will be right here, 1, 2, 3, 4. So we only had 4 scenarios where there are 3 flights on time. That meant there's only 1 late.
Then you put the 3 with the 0.7.
And so that has a probability of 0.41415. And final option, all 4 flights on time,
1.
and that there was only 1 of those. And if they're all on time, that's 0.79 to the 4th. And we get 0.385 or 38.
So that exponent is how many is on time?
Yes.
Or not on time?
It's the same number of time.
Yeah. So it's like
Okay. So we can do that, but there's got to be an easier way, doesn't there? I mean, this was kind of a pain for only having 4 flights. What if I said we have 16 flights? Do you really want to have to do this? Oh, whatever. So we need a better option. This is a binomial experiment because either you're on time or you're not. The flights are independent. They all have the same probability of being on time. So we have what's called the binomial distribution for this. What you want to write down. So it's right here. It is on your formula sheet. P is your probability of success. A lot of times, I might write mine a little different. Instead of 1 minus P, I usually just put Q. Because Q is the same as 1 minus P,
Put the X
probability of
equals.
failure. No, they're just going to be integer values. So this is a formula that allows us to calculate various things. The NCX, that is what's called a combination. We can do that on our calculator. if, for instance, in my example, we had 4 flights, let's say I wanted the probability of 2 of them being on time. So 4, choose 2 to be on time. The probability of being on time was 0.79, and there are 2 on time. Probability of not being on time would be 0.21, and if there are 2 on time, that would mean there were 2 late, right?
Wait, is that you using the formula?
So, we can do this on our calculator. What you need to do first,
Wait, so what's the n minus x?
same thing as 2. It's probability of failure. Type a parenthesis, and do 4, go into math, over to probability. We did this in Algebra 2. And I might have did it as an ACT review last year with you guys. So we want, this is a combination, we want number 3, NCR. So what I'm telling you, in your calculator, we did parentheses 4, go math, probability, number 3, the NCR, and then we want to choose 2. Close the parentheses and then type in the rest. 0.79 squared, 0.21 squared. Is that the same thing I got in my table for the probability of 2 flights being on time?
Will you make us do one of those weird tree things on our test?
Formula to help us, and again, it's on the formula sheet. So we're going to look at a new example. According to the Experian Automotive, 35% of all car-owning households have 3 or more cars. In a random sample of 20 car-owning households, what is the probability that exactly 5 have 3 or more cars? So let's write down a few things. What is my N here? 20. P, the probability of success, what would that be in this case? Right, it's probability that you have 3 or more cars, so that's 0.35. So that means my Q, the probability of not having that many, would be 1 minus 0.35, which is. So now, the probability that exactly 5, so the probability that x equals 5. We can use our formula for that. It would be 20, choose 5, 0.35 to the 5th power, 0.65 to the if I have 20 and 5 have 3 or more cars, then how many don't? 15. If you look at your formula, that's the n minus x power. So 20 minus 5 is 15. And then we can type that in our calculator. 20 NCR 5. To the 5th. And make sure you're plugging this in, not just waiting for me to write it up here, because you need to know how to put these in. The 9 is nice.
Looks weird. It looks like
Very
Frank.
inconsistent.
Yeah, it looks like Frank. Sometimes like, you need to use 2 decimal places, then it's like, why not use 17?
Alright, so we get 0.1272. So we got that. So B. What is the probability that less than 4 have 3 or more cars? So less than 4 means, what could it be?
0, x equals 16.
Well, it could mean that x is 0 or
So you're just
1.
gonna do it like x equals 16 and subtract that?
No, because that would be that they had exactly 16. You have to do everything in order. So we just want less than 4. So could have 0, 1, 2, or 3. Right. So we would have to calculate all 4 of those things and add them together. Okay. Let's try that real quick. You can put it all in the calculator. So the probability of 0 would be 20 choose 0. So 20 NCR 0. 0.35 to the 0. 0.65 to the 20. I'm just going to keep typing. Plus. The next option would be 1. So 1
Can you do that? Like just
NCR, sorry, 20 NCR 1. 20 choose 1.
would it be like a 0.35 or
Then 0.35 to the first. 0.65 to the 19th. Plus, then we would have 20 choose 2. 0.35 to the second. 0.65 to the 18th. And then we would have plus 20 choose 3. 0.35 to the third. 0.65 to the 17th. Lucky for us, we have calculators, so we can just push a bunch of buttons and get this. I get 0.0444. What's the probability that at least 4 have 3 or more? So at least 4 would be 4, 5, 6, 7, all the way up to 20. We can calculate all those and add them together.
Or you can just do 1 minus 1.
Didn't I just find the probability that you had less than 4? So the probability that you have 4 or more would be 1 minus the probability that it was less than 4, which is 0.0444.
That's like what I was trying to say, but like before, like if you just found like 6, or I guess it'd be 17 or more. Like,
But that would give you too much because then you have 16, 15, 15,
Yeah.
so it would. So we get 0.9556.
Is it like not easy right
Oh, maybe. So the probability that it's between 3 and 5. I should specify, let's say 3 and 5 inclusive, including 3 and 5. I will on the test make sure I put the word inclusive to tell you to include those points. So then, yeah. So that means you could have 3, or you could have 4, or you could have 5. So you could type all these in the way we did the previous one. You could calculate them individually. We've already found the probability that you have 4, we found the probability of 5 up here. So the probability of 3 would be 20. Math, probability, NCR 3. 0.35 to the third. 0.65 to the 17th.
So is your first one, how much is the one right after your C?
So if you want to do these individually, you can. The nice thing is if you're just bringing that up, you can just hit second enter and adjust your numbers if you choose to do that. And add all those together. Or you could have just entered everything in the calculator once to begin. can do this by hand. Do we want to? On this problem, right? So if you look at this binomial table, it has your n values in the first column. It has all the way up, it does 2 through 12, and then 15 and 20. So we would have to go to an n equals 20. Across the top was our P, our probability of success. What was the probability of success in this scenario? The 0.35. So if I wanted the probability, the very first thing was that exactly 5. So I go to my 20. Then I go to my x value. So n is 20, my x was 5. Go over to your 0.35 column, and you get 0.1272. Okay, so you have to read your n, your x, and your p on this table. The nice thing about this, if I said less than 5, now all you have to do is add up the tables the numbers directly from your table. So it's much easier. So you don't have to just calculate all of them. Now, if I gave you a probability of like 0.37, that's not on the table, so then you have to do it by hand. Or if I gave you an n value of 35, the table doesn't go up that big, so you have to do it by hand. So the table doesn't save you from all the work, but some cases. Okay? Okay.
Did we get this on the test?
Yes. I will add this to the formula sheet that you get on the test. All right. So next thing, the mean and standard deviation of a binomial. Very simple calculations to do. The mean is just n times p, the number times the probability of success. Standard deviation is the square root of n times p times 1 minus p, or a lot of times I rewrite that. 1 minus p is the same thing as what? Q. So a lot of times when I write it, I'm just going to say standard deviation is the square root of n times p times q. So no ugly tables to make in order to get standard deviations for this distribution.
Stapling it to the other columns.
Stapling it to my extra copies that I can do with your functions. All right. Are we ready for an example? Or do you guys have these formulas written down? The same problem that we were just doing. So we have 35% of all car owning households have 3 or more cars, and a simple random of 400. So what is my n? My p is still the 0.35, which means my q is still. I want the mean and standard deviation. So the mean is just n times p. And we get 140. Standard deviation is just the square root of n times p times q. And I get 9.8. death penalty for individuals convicted of murder, in a random sample of 15 adult Americans, what is the probability that exactly 10 favored the death penalty? We are going to use our table for this. So what is my N value?
15.
What is our P value?
0.65.
So what is the Q?
0.35.
Okay. So I want the probability that we have exactly 10. So you are going to go to your table. Your N is 15. So you are looking on the very back page, right? My P, looking at my 0.65 column, and I want X to equal 10. So what do you get for that probability?
Wait, can you find your?
I think it's 0.1906. 2, 2, 3. Okay, I don't know.
Yeah, you might need another sheet of paper to kind of cover up and make sure you're reading straight across on
What did
these.
you guys get?
0.2123. Does everybody see that? B, no more than 6. So that's saying probably X is less than, does that include 6?
Like no more than, yeah.
Yeah, less than or equal to 6. We can have 6. Okay, so you are going to go to your 0.65. You'll notice, like, for the 0 and 1, it has 0.0000 plus.
I mean, it's not 0, but it's got the 4 decimal places.
We only go to 4 places in this table, so it means the first 4 digits are all 0. The probability itself is still a positive number, but it's extremely small. So for our purposes, we just kind of ignore those. So we are adding up the probability. See, 0 and 1 are both 0, so we'll do the 1, 2, 3, 4, 5, 6. So we're just adding up those. And we should get 0.0423. Hopefully significantly easier than actually calculating each of those numbers on your own. Just read them from the table. Any questions on that?
What did you get?
So, I have like 2 examples left on this that I will finish tomorrow. And then we will have time, we'll talk a little bit about what to expect on your quiz. And then we will have some work time. Here is the assignment. It's fairly short, really, so tomorrow I'm finishing the notes, doing some quiz review problems, and you'll have some time to work on this. Problem 36, I just want to clarify. It has multiple parts, and on each part it tells you to interpret. I am not going to make you write the interpretation on every